This is the standing waves experiment using microwaves. Microwave transmitter. This is a microwave probe which has got a built-in speaker, so you can't hear microwaves ordinarily. The probe will, whenever it detects microwaves, will convert that into an audible signal, so that we'll be able to hear when we're receiving microwaves there. And I have an aluminium sheet here as well. I won't be using that at the moment. What I'll do first is show you what would happen without a standing wave being formed by the microwave. So I'm going to turn on the microwaves now, so the microwaves are being sent out. That's us receiving the signal. That's us receiving the signal through the microwave probe. And you can see that's the difference. So I'm receiving a signal, and as I move the probe down parallel to the ray of microwaves, I should see a fairly continuous signal. It may get a little weaker as I move it away, but it should be fairly continuous. So that's what it sounds like as I move it without the aluminium sheet. I'm going to put the aluminium sheet here. This will reflect the microwaves back towards the transmitter. So what I have then is two waves of the same type moving in opposite directions, and they have the same frequency and amplitude. So they should meet and superimpose in this region, forming a standing wave. The wavelength is about a centimetre, so I should detect, if there's a standing wave, I should detect antinodes and nodes. Nodes will be places of minimum signal, and antinodes places of maximum signal. So I should get that pattern occurring along here, so I'm going to investigate that now. So I'm getting that oscillating signal that's going between maximum, minimum, maximum, minimum, maximum, minimum. The maximum is where there is an antinode, and the minimum is where there's a node formed. And if I do that more slowly, so you can clearly see those maxima and minima that are appearing here when the microwaves are on. So I do indeed have a standing wave being formed here.